Pre-Algebra, Mr. Lawrence here with your flipped lesson for Thursday, March 29th. This is the test review. You have a test over transformations. All right, I'm just going to quickly go through them and how to do them. I'm not going to do an example of each one. You've got the videos from the past couple nights you can go back and watch to help you study. All right, the first type of transformation that we learned about was called a translation, right? A translation. And to perform a translation or tell if something's been translating, all it means is it's been shifted, right? And you have to tell me how it moved. So if I have this arrow right here, okay, maybe it moved. Let me get it to look slightly different. Maybe it moved up 1, 2, 3 over 2. So it would be up 3, right 2. Or it could be expressed as 3 over 2, right? Okay, so that's a translation. The next type we worked on was a reflection. And for this one, I'm going to get some graph paper out here. Here we go. And you know what? If the graph doesn't mark it, the first thing you should always do, put the origin on, put the x-axis and the y-axis. All right, let's take our friendly old, well, arrow is not a very good example because you can't tell when certain things have happened to you. Let's take this check mark, okay? Okay, now remember there's really 4 different types, actually 2 different types of reflections, but you can break them up into 4. We might have the mirror be the y-axis, in which case this is the y-axis. And when I reflect this guy, A is 1, 2, 3, 4, 5 away from the mirror, so it's going to be 1, 2, 3, 4, 5. The new A prime will be there. B is 1, 2, 3, 4, 1, 2, 3, 4. All I'm doing is counting the distance from the mirror. C is 1, 2. I didn't label that C. 1, 2. And there's C prime, A to B, boom, piece of cake. And the check mark looks backwards, right? Because it got reflected. Then again, the mirror could be the x-axis, right? In that case, the mirror, the check mark is going to end up underneath. And I just do the same thing. B double prime would be here. A, 1, 2, 3, 4, 1, 2, 3, 4. It's all based on how far you are from the mirror. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. And there is C double prime. All right, there you go. Okay, now, if you have a different situation where maybe there's a line that's the mirror. Now I'm actually going to do those, but I'm going to talk about identifying the mirror. Let's see if on your own you can identify where the mirrors are for, say, x equals 3 and for y equals -2. All right, let's do the x equals 3 first. If you're not sure, I know you guys are pretty good at this, but write down a couple of points. And the only rule is that x must equal 3. 3, 1, 3, 2. How about if I go 3, 0? And I'm going to plot those points. 1, 2, 3 in the x direction, 0. 3, 1, 3, 2. There's my mirror. My mirror has to be a vertical line going through there. So that would be my mirror. I would count the points distance from the mirror. Now, if I do y equals 2, same thing. I'm going to write down a couple points, except the rule is this time y equals -2. Yeah, that's the rule. How do I know? Because it says y equals -2. So for each one of them, I'll do -2. So I'll fill in some values, maybe 5, maybe -1, maybe 0. 0, -2 would be right here. 5, -2, 1, 2, 3, 4, 5, 1, 2, right there. And then -1, -2 would be right there, right? And so I would go like this. Okay. And then I would just count the distance to that mirror. So it's really only 2 types of reflections. You just got to make sure you can identify the mirror. Most of you can do x-axis and y-axis without a problem. And then if it says x equals 5 or y equals 7, then you got to find that mirror. Okay, so another type of transformation we learned was the rotation. Okay. Okay, and I'm not going to do a whole rotation again. You can go back and watch the old videos. Okay, but rotations, we know 2 types. rotations, okay? Type 1 is the 90 degrees, all right? And you have to, for this one, determine if it's clockwise. And remember, if you forget this, you look up at the clock and you watch the right hand move. Clockwise would be like that, okay? Or if it's counterclockwise. Now, the story should tell you, the problem should tell you, but you have to make sure you know. Okay. And that would be counterclockwise, going the other way. Now, remember, in a graph, right, you have 4 quadrants, okay? Quadrant 1, 2, 3, and 4. Okay. Now, when you're in this first quadrant, positive, positive, right? This quadrant is negative, positive, negative, negative, and positive, negative. All right. So you're in this quadrant. If your original shape is, say, here, okay, when it rotates, let me give you something more obvious. Let me use that arrow from before. Where is my arrow? Okay. When it rotates, it's going to move 90 degrees either to the second quadrant or the 4th quadrant. And what you'll need to do is decide which quadrant it is based on clockwise or counterclockwise. And then you will know, that could be, if it were clockwise or counterclockwise, excuse me. And this would be as if it were clockwise. Okay, something like this. Now, I'm not using coordinates yet, but I will in a minute. All right. What you need to do is use your coordinates. So maybe A was at 3, 2. Okay. B was at, I don't know, 4 or 5. Okay, I'm just making them up. For 90 degrees, you're going to switch A and B, X and Y. You're going to switch them. So A prime would go to 2, 3, and B prime would go to 5, 4. But then you have to remember how to get the sign. Okay, sorry about that. I got interrupted. So now I got to determine what the sign is, right? What the sign is. So I'm going to remember that if I did this yellow one, I'd have a negative and then a positive, right? X would be negative. Y would be positive. X would be negative. Y would be positive. If it was the 90 degree counterclockwise one. If it's the 90 degrees clockwise one, X is going to be positive and Y is going to be negative because of the quadrant I end up in. So it's all based on what quadrant you're in. All right, now the 180 degree rotation is simpler. The 180 degrees, they don't have to tell you clockwise or counterclockwise because you end up in the same place. And all you have to do are change signs. So if A is at 2, negative 5, A prime is going to be at negative 2, positive 5. If B is at 0, negative 2, B prime is going to be at 0, 2. You just change signs. 0 doesn't have a sign, so you don't change anything. You just leave it neutral. But the other ones, you just change the signs. If C was at negative 3, negative 4, then C prime would be at 3, 4. You don't have to do anything but change the signs. In that sense, it is so much easier, I think. Okay, let me see. I've covered rotations, translations, reflections. I still have to talk about dilations. And the dilations, there are 2 types once again. And again, for better examples, go back and watch a previous video. The past couple nights have some very good ones. All right, there's 2 types, right? One is with the origin at the center. And then the other type is with the point of the polygon or whatever you're dilating at the center. Okay? And remember, you're going to need to know the scale factor. You must know scale factor. Okay? Let's say you're going to do one at the center, the origin at the center, with a scale factor of 2. Well, you're going to take all your coordinates, 1, 5, B might be, I don't know, -3, 7. I'm just making these up. And all you're going to do is multiply each coordinate by the scale factor. So A prime would be 210. B prime would be -6, 14. Okay. Now it's possible that your scale factor could be a fraction, right? In which case the thing would get smaller. Well, in that case, you'll divide by 2. So A prime in this case, I'm still using the original A and B. A prime would be 1/2. And B prime would be 5 divided by 2, which is 2.5, right? B prime, I'm sorry, that's the y coordinate. I think I said B prime. B prime would be divide by half. 3 divided by half would be -1.5. And 7 divided by half would be 3.5. Okay? So the scale factor could be 2, or it could be 1/2, it could be 1/3, it could be 3. Okay? So you just multiply the coordinates. Now, with one where a point is at the center, that's where you need to know. Let's say we have this rectangle, A, B, C, D, and I know that A is going to be at the center. I'm going to circle A. Let's do the scale factor of 2. Okay. Well, let's pretend that this distance from AB is 4 units long. All right, we're going to make this 3 units. We're going to make this 4 units. All right. Well, A is not going to move. The new AB will have to be twice as long. And so that would have to be 8 units. How do I get that? 4 times 2 is 8. Okay. The new AD, boom, boom, would have to be 6 units long. 3 times 2 is 6. And then I could just draw to complete my rectangle. Okay, that's with the scale factor of 2. Now, if the scale factor is 1/2, well, let me get rid of all these blue ones, get them out of my way here. The scale factor is 1/2. Let's disappear, thank you. Well, I'm going to do the same thing. A is still circled, it's not going to move. Now the distance from A to B was 4, so the distance from A prime to B prime is going to be half that, divided by 2, right? Okay, and this is 3, so it's going to have to be 1.5 or 1.5, and that'll be D prime, and then I just take them up, and C prime will end up being there. Okay, so that's it. Also, don't forget the magnification problem. Set up a proportion or divide. All right, again, you can go back and watch previous videos. Mr. Lawrence signing off. Good night, everybody. Oh, I wanted to tell you, there will be a video over break. You'll want to watch it near the start, near the end of break, so that you're ready to go on the Tuesday we come back. Okay, we only have about 2 weeks and a couple days, and then we're going to be at OAA time. So, Mr. Lawrence signing off. Good night, everybody.